So I'm back with another vintage audio video, and I'm using, of course, vintage test equipment to test vintage audio gear, since I'm kind of a vintage person myself. So in this video I am going to be testing or trying to test the loudness control. Before, when I checked this unit, I think I tried the tone controls, bass and treble. Of course, as we all know, the loudness control that basically offsets the losses of the human ear when you hear something at reduced volume. And what we're going to do now, we're going to have to test the volume control at a low level, because that's when the loudness control is supposed to be used. At really low levels, the human ear is not really that sensitive to low frequencies, and also is not supposed to be that sensitive to high frequencies. So in the specs it said they test at minus 40 dB. So what is minus 40 dB compared to what? Well, that's compared to full output. Like, for example, this unit puts out 20 watts per channel, and if I were to hook up a AC voltmeter, or rather I do have one hooked up at 20 watts per channel, this amp will put out 12.7, or rather the amp in the receiver, this is a receiver, that'll put out 12.7 volts AC if I have an 8 ohm load. And that's going to be the full output, and then I'm going to go ahead and go 40 dB down, which is 1/100th as much. So basically it's going to be 127 millivolts. That's what I'm going to test is at. Because at a high level, the loudness control is not supposed to work, so it wouldn't make any sense to check it that way. It works at basically when we have the volume control low. That's when it's used. Maybe I can show that. Maybe I can show that too. Here's another quick look at the specs. If I hit the loudness button and I feed in a test signal of 100 Hertz, my pointer on the voltmeter should go up by 6 dBs. And if I feed in a test signal of 10 kilohertz or 10,000 Hertz, that pointer should go up by 3 decibels. Also, before I forget, all the controls are in neutral position. Bass is treble is neutral. Balance is in the middle, of course. Loudness is off right now. The old voltmeter I'm using here, this is an old HP 334A distortion analyzer. The 8 ohm dummy load, and these are the leads, test leads from the voltmeter from the HP 334 across basically the dummy load terminals. And right across here I'm probably going to hook up an oscilloscope now just to monitor things on the other channel. And this is the old National basically audio generator I'm using. It's going to put out the sine waves that we're going to be feeding in. So my next step is turning up the volume control to maximum while having the audio generator turned all the way down. So I've got it wide open, and then I'm slowly going to go ahead and bring up the amplitude of the signal I'm feeding into the receiver. So I don't know if I mentioned this a few minutes ago, but this unit puts out 20 watts per channel. Basically, with 20 watts per channel, it should be putting out 12.7 volts AC with an 8 ohm load. So I'm going to bring up the audio generator until I get about 12.7 on here. and that's going to be basically maximum output, maximum or rated output. So I'll go ahead and slowly start bringing this up. Should be doing something. And I'm going to stop at 12.7. I am actually right now, I'm on a 30 volt scale here. And 30 would be right here where my finger's pointing at. 10 volts right here, 20 right there. So it's going to be right around there somewhere. Let me go ahead and get a little bit better focus here, or rather closer in. So again, it's right here about, it's at 10 volts right now. You can see the 1. So go ahead and, I think it's 10, 11, 12, and I said 12.7. That's too much. So I'm going to have to go incrementally up. So I think that should be right around there. Again, now I'm at max output, but the testing I'm going to do is at minus 40 dB, which is 1/100th of that. So, and 1/100th of 12.7 is 0.127. Of course, 1/10 of that, if we were 20 dB down, would be 1.27 volts. But here it's going to be 0.127 volts because it's 40 dB down, meaning this is going to be 1/100th as much. That's what we're going to be testing at. The scope signal at full output. So now I'm at full rated power output, and I'm feeding in a 1000 hertz sine wave. The loudness control is off. And what I'm going to do now is bring it down 40 decibels. Bring the volume down, volume control down 40 decibels. That's going to be 1/100th as much. So full power output here is 12.7 volts, and 1/100th of that is 40 decibels. So I'm going to be going to 0.127 volts, or rather 127 millivolts. If we were to be down 20 dB, we would be using 1.27 volts, but we're down 40 dB, so that's 100 times less than the 12.7 volts. That's going to be 127 millivolts. So we turn the volume control down. Also, I have to change the range on the meter. I'm going to go down to 0.3 volts. And I'll try to park it on the needle on, same thing again, about here. I can't see it exactly here because I'm behind the camera, but I think I'm pretty close. I'm going to leave it at that. So now I can finally go ahead and use the loudness control. And what I'm going to do is first feed in the low frequency signal, which is 100 hertz, and I should see a 6 decibel change. So let me do that. Let me go ahead and dial this in here so it's exactly on minus 6 dB. A little bit won't make a difference, so I'm going to go ahead and turn down the volume control just a little bit. Now I can read it a lot easier this way. And let me dial in 100 hertz. So now when I hit the loudness button, we should have a 6 decibel increase. I don't know if I can focus in here. If you watch the right here where my finger's at, you can see the minus 6 dB. I've got it basically on there. Now, if what I said is correct, it should, the pointer here, the needle, should go all the way up to 0, because it said it would boost at 100 hertz, it would boost 6 decibels. So from minus 6 to 0 is basically plus 6. So I'm going to hit the loudness control now. And we can see basically it's almost about a little bit more than 6, it seems like. So, in fact, I think I have it set up for a little bit higher than. Problem is I'm behind the camera and I can't really see that well. We'll try that again. So it should end up at about 0. Okay, it's a little bit more, but no cause for panic. So now we'll go ahead and try the 10,000 hertz frequency, and there you're supposed to get a 3 decibel boost. So now we try 10,000 hertz. I've got the audio generator changed, and let me go ahead and adjust the volume a little bit so I get it right on the minus 6 here. And now when I hit the loudness switch, we should see a 3 dB jump. Well, it should go from minus 6 to minus 3, which is right there where I'm pointing at. Minus 2 is right there. And of course 0 is all the way right there. So, I mean, we're not 100% straight. I really have a problem seeing behind the camera. Camera's basically in the way. So, let me go ahead and hit the loudness switch, and we'll see if that magic happens. Okay, so, well, it went up plus 4. Well, 1 dB more, which isn't the world, but I think that happens quite often. You expect to measure something and it doesn't really turn out that way. It's not that, basically not that critical. One thing I do want to show before I stop this video or end this video here, I want to show the difference, say, if I have it if I have the receiver at full output and I use the same frequencies, or I'm going to use one of these frequencies, then I hit the loudness control. And if your loudness control is working properly, you shouldn't see such a big jump, because, you know, as the loudness control says, you use it when your volume is low. That's what that's for, to boost the bass and the treble often when the volume's low. So the higher the output of the receiver, the less should actually happen with these pointers here. So let me try that. So here we go with 10, basically 10,000 hertz, but the difference is the volume is turned almost all the way up. I'm going to turn it down a tiny bit so I get here, so the pointer goes on the minus 6 here, so I don't have to do any mathematics. So now I have the loudness control off again now. So when I hit it now, that needle should not move as much as it did last time, the pointer. It shouldn't go 4 dBs up. So it should only go up maybe a little bit, if at all. So we'll try that. Ready? Here we go. In fact, it actually went down. So, which is okay. So now we'll go ahead and try the 100 hertz frequency. Let me get that set up. So now we're feeding in a 100 hertz. Again, I'm about almost at maximum power output. And again, not as much should happen as when we were down at minus 40 dB. So I'm going to hit the loudness control right now. Oh, I have to make sure I get this pointer on minus 6 here. Let me Now you might notice that, for example, when you change frequencies too, that this might move. That might have something to do with your amplifier or receiver. If it doesn't have a perfectly flat frequency response at all frequencies, or could even be, depending on the meter you use, could be your meter. It could even be your output generator that it doesn't put out, because it needs to put out a constant voltage at all frequencies, and some just don't do that. So that would have to be checked too before you start. So we'll go ahead and hit that loudness control now. I wonder what, I think it was at 100 hertz earlier when we were using it at the minus 40 dB level. It was plus 6 dB. It went from minus 6 to 0 all the way here on the right where my finger's at. So, okay. In fact, it didn't even move, well, only part of 1 dB, maybe 1/5 of 1 dB. So that's exactly how it should function. Well, let me go ahead and turn down the receiver. I don't like running them at full output anyways, even though they can take it, or should be able to. Anyways, I hope this was halfway enlightening. Thanks for watching.